Given the following biconditional statement, a quadrilateral is a rectangle if and only if it has 4 sides, we have to first provide a counterexample for why the biconditional statement is false, then rewrite it to make it valid. If I look at this, I see a word that we haven't really talked about before, which is called a biconditional. This statement is my biconditional statement. A quadrilateral is a rectangle if and only if it has 4 sides. A biconditional is noted with that phrase, if and only if. And basically what that means is I can read it as both the conditional statement and its converse. So if I write the biconditional, a quadrilateral is a rectangle if and only if it has 4 sides, it's the same thing as saying if a quadrilateral is a rectangle, then it has 4 sides, and the converse. If it has 4 sides, then the quadrilateral is a rectangle. So a counterexample for this, we think about this. Do we know of any 4-sided shapes that are not rectangles? And the answer to that is yes. A square would be a counterexample, because a square has 4 sides and it's not a rectangle. A rhombus has 4 sides and is not a rectangle. A trapezoid has 4 sides and is not a rectangle. We can rewrite this to make it valid by creating a statement that is true about rectangles. So I could say a quadrilateral is a rectangle if and only if it has 2 pairs of opposite congruent sides and 4 right angles. Right? A rectangle has opposite sides that are equal and 4 right angles. So that would be a definition of a rectangle. Generally, we make these biconditional statements valid by writing a definition.